Okay, example 2, I think we have to do example 2 and 3, and then one other thing on linearization, and then this video should be fairly short. This one, you have a balloon that's going up in the air, okay, and there's a rangefinder over here. Could be a rangefinder. Camera is a very popular kind of thing. So there's the rangefinder. And then you can see this one makes a right triangle also. Okay. So now this one says the hot air balloon rises straight up, so it's going up. It's tracked by a rangefinder on the ground 150 meters from the liftoff point. So that's never going to change. That's always going to be 150 meters. So that's going to be stationary. There's no variable there. At the moment, the rangefinder's angle is pi over 4. So at pi over 4, at that angle, this angle is going to be changing, but it's going to stop at some point when it gets to 45 degrees. We know the angle is increasing at this rate. So this is d theta dt. This is the rate the angle is changing. It says how fast is the balloon rising. So our other variable we want to put there because we want to figure out the speed dy dt of the balloon. All right, at that moment. So what you're going to do whenever you have an angled kind of problem, you always pick a trig function. So this one is tangent. So tangent of our angle is y over 150. So we'll write this a little bit nicer so we can take the derivative a little bit easier. All right. So now we take the derivative. We got our formula. We got our two variables. The derivative of tangent is secant squared. Angle stays the same. Derivative of the angle is d theta dt equals 150 comes along. Derivative of y is dy dt. So now we just fill in numbers. So it gives us the angle this time. We actually don't have to figure anything out. We're going to change this to cosine. So when we punch it in our calculator, it'll go a little nicer. So we'll put in 45 degrees or pi over 4. It doesn't matter, whatever you use. So it's squared. D theta dt is 0.14 radians per second, I believe. And then 1 over 150. And then we're trying to find our change in y, how y is rising. Okay, so what you do for this one is you put in 1 over cosine of 45 squared, times it by 0.14, and then multiply it by 150 to get the dy dt alone. Okay, so let me do that real quick. Calculator. And I think it comes out with an even number if I remember correctly. So 1 divided by, and then cosine, 45 degrees. And you want to square that, and then multiply by 0.14, and then multiply by 150, and you got it. Yes, 42. So the speed is 42 dy dt, and let's look for the speed, feet per second or something like that. Let's see. So it's per minute, and it's meters. So it's meters per minute. So meters per minute. Okay. So that's the speed of the balloon. So whenever there's an angle, it's going to be some type of trig function there to do. Number 3, I believe, is the other one that we didn't do. This one is actually a Pythagorean theorem problem. We have a police car, and it's approaching an intersection from the north. And then we have a bad guy. So this is the police here, the cruiser. Okay, and then we have a bad guy. He turns the corner and it's going right. Right, so it says speeding car, so we'll call him the bad guy. So you can see there's another triangle here with this one. So this one, as the police is going towards the intersection, this is changing. Y is actually getting smaller, and then as the bad guy is going to the right, X is getting bigger. So now, unless Y and X actually change at the same rate, this distance between them is going to change. So that's never going to stay the same because, like in our ladder problem, that stayed the same, but this one's not. All right. So this one actually is one of the few problems, and I think the only one we've had so far that is Pythagorean theorem that has 3 variables. So every single one of those distances is changing. So when you take the derivative, and then we'll sub in numbers, we'll see how this all goes, dy dt, and then 2z dz dt. And then after you do that, you can cancel the 2's. Okay, so now it says something. It says the police cruiser approaching the right-hand angle from the north is chasing a speeding car that's turned the corner and is now moving east, which is what we have there. So the bad guy was moving east, which is to the right. When the cruiser is 0.6 miles north of the intersection. So when the police car is 0.6 miles north, so that's going to be X. The car is 0.8 miles to the east. So the bad guy, which is our, my bad. I have this backwards here. All right. So the bad guy is 0.8. So this should be 0.8. And then the police cruiser is the Y guy. So that's 0.6. So I had them backwards. All right, so now we don't know Z. We don't know this distance here when this one is 0.6 and this one's 0.8. So this is the one where you put it back in the Pythagorean theorem. And for Z, then you get 1. So this is one that we've had one like this before that you get, you have to do Pythagorean theorem. Okay, so now let's see if it gives us the speeds of these things, and we'll put that in. So it says, police determine with radar that the distance between them and the car is increasing at 20 miles per hour. Okay, here's the police, and then the cruiser or the bad guy is back down there in the corner. So our Z is changing by 20 miles per hour. It says if the police cruiser is moving at 60, so the police is moving at 60. Now here you have to be a little careful. The dy dt, which is 60, has to be negative because y is getting smaller, right? So what we want to solve for is what's the speed of the car? We want to figure out how fast the bad guy's going in that case. So what you do is you just do a little math here. This will be negative 36. Negative 36, and then equals 20. So eventually, what you do is you're going to add 36, and you get 56, and then you divide by 0.8. So this one, divided by 0.8, and you get 70. So the speed of the car is 70, and it's probably miles per hour. Let's look. So the speed of the car is going faster, and that makes sense because the bad guy is gaining on the cops. He's gaining on the cops. Okay. All right. So that completes those related rates problems. So the last thing we have to do is a problem on linearization. Linearization. This just means it says find the linearization. That just means find the tangent line. That's all it means. Tangent line. So what we're going to do is we're going to find the tangent line first, okay? After we find the tangent line at x equals 3, what we're going to do then is we're going to find what the value of 3.1 is, okay? So what you could do is you could actually plug in 3.1 into here, and that would be an exact value, but we want to get an approximation for this, because we just don't want to plug 3.1 into the function. We want to get an approximation of it using a tangent line. So remember, when you're using a tangent line, what you need to do is you need to find the slope first. So here's our equation. It's 1/2, it's 1 plus x to the 1/2, 1 plus x to the 1/2. So the derivative is 1/2, 1 plus x to the negative 1/2, and then the derivative of the inside is 1. So now what we do is we plug in 3. Okay, plug in 3. So when we plug in 3, because that's what it said to do, you get 4 to the negative 1/2. All right, so this is 1/2, and then this is over the square root of 4. So our slope is 1/4. All right, so that's our slope, is 1/4. So our tangent line, we got to find b. So y equals mx plus b. So now you have to find the y guy initially when you do that. So when x is 3, you plug in 3, you get the square root of 4, which is 2. So our y guy is 2. So here we go. We'll find our b, and then we'll find our tangent line. All right. So our y guy is 2. Our slope was 1/4. Our x guy is 3, and then plus b. So eventually, you get 2 minus 3/4, which is 1 1/4. Right. So our tangent line is y equals 1/4 x plus 1 1/4. Okay. So now, what you do to figure out 3.1 is the estimation. So when x is 3.1, what you do is you just fill it in, and you'll figure out the y. So 1/4, and then 3.1, you fill in, and then plus 1 1/4. And then that'll give you the y guy. So that'll give you an approximation for the square root of when you put in, which actually would be 4.1. So when you do that, you put 3.1 and divide it by 4, and then you add 1.25 to it, right? So the y is 2.025, and that's your answer. So what you're doing is you're using a tangent line to approximate a value, okay? So that's what you're doing there, is you're using that tangent line to approximate a value of 1.3 if you plug that into the function. So if you actually plug that into the function, you would get the square root of 4.1. All right. So if you want to just kind of see how close we are, the square root of 4.1, when you would actually plug that in there. So I'll plug it in, and you'll see that it's fairly close. So square root of 4.1. Yeah, so it's fairly close. So if you actually do that, it's 2.0248, so forth and so on. So you can see the answer, the actual estimate is relatively close. Okay, we got really pretty close with just using a tangent line to approximate that. Okay, all right. Number 10, letter A, is this one says find dy. So what you're going to do is you're going to take the derivative for that. So the derivative of y, remember, is y prime. But we can also say dy dx in this case. And then equals the derivative of x to the 5th is 5x to the 4th. And the derivative of 37x is 37. Okay? So now it says find dy. All right? So dy is going to equal dx times 5x to the 4th plus 37. And that's what they wanted in part A. So that's part A. They wanted to just find what dy would be. And then this one says find the value of dy. So letter B. Find dy when dx is 0.2. And then your x value is 1. So 5, 1 to the 4th plus 37. So you just figure out what that'll be. So you plug that in, so you get 5 plus 37, which is 42, and then you multiply that by 0.2. Get your answer, which is 8. Okay? So that's linearization. Linearization just means use a tangent line to approximate another value. That's all it means. Okay? All right, I think that concludes everything in the video. Yeah, the next part is homework problems. All the answers to those are at the very, very end of the packet. Just the number answers. And so if you had trouble with those, give me a holler. Thanks.